Bismillahirrahmanirrahim. So welcome to this lecture. It is about the interaction of radiation with matter and the loss of energy after the interaction of the radiation with the matter. And in the previous video, you have already learned the general interaction of the radiation with the matter. It is the ionization or the excitation. So here, this is the simple definition of the ionizing radiation, which is the radiation that has sufficient energy to remove the electrons from the atoms and creating the ions. And that's why these are called the ionizing radiation. So ionizing radiation can be classified into the two groups. One is the particles, mean alpha and the beta particles, and the other one is the photon. And photon, here we are going to discuss the gamma, and it may be the X-rays. So this is the actually the way how the radiation are going to interact with the particle, if it is the matter is going to interact or the energy is going to interact with the matter. So let's see what are the different processes over here. So we are going to first discuss the interactions of the radiation with the matter, the part one. And here, this is the actually the image over how the alpha, because alpha particle or the beta particles are going to interact with the matter. And this is the alpha particles ionize by attracting the electrons from an atom. So this is the atom. Let's suppose this is the any material which is having the different atoms over here. So alpha is having the positive charge. So it may attract the electrons in the atoms. So the electrons may be ejected from the orbital electrons, so they can ionize in this way. So when it is removed, so leaving after removal of the electron, it is leaving the positive charge on the atom. So that's why these are called the ionizing radiation. These are going to ionize the matter. So for the beta particle, so beta particles ionize by repelling an electron from an atom, because beta is having a negative charge, basically the neutron, and when there is the having the similar charge, and when they having neutron is having minus charge, this electron is also having the minus charge, so they may repel to each other. With the repulsion, it may remove from the orbital or from the outermost orbital. So that's why the beta particles has also ability to ionize the material. So this is the way how the matter or the particle are going to ionize the matter, the atoms present in the matter. So let's discuss first with the alpha, and then we will move to the beta particle and beta, the neutron and the positron. So for the alpha particles, and with the interaction of the alpha particles and how it is going to lose its energy. Again, we have already discussed these are the ionizing radiation, because they are going to ionize the material. And this is the first point. Alpha particles being heavier continued on a straight line path, whereas electrons produced as a result of ionizations are scattered through large angle. So because alpha is having heavier, because having two protons and the neutrons, it is the helium nucleus, and it is going to pass through the material in a straight line. And when it is going to pass through a straight line, it may eject the electrons having the because of having ionization power, but these are the electrons having minus charge, and they may be scattered with the large angle. But here, this is the important application over here. The alpha particles are going to pass through a straight line in a material. Second point is, following each collisions of the alpha particles, kinetic energy, which is in the range of about 5 mega electron volt for most of the alpha decays, is transferred from the alpha particle to the interacting electrons. Because alpha is having the ionization power, it is going to interact with the electrons, so it transfers its kinetic energy to the interacting electron over here, and then they will move from the material. So this energy is sufficient to produce ion pairs, and the process of ionization continues until the alpha particles have lost all of their energy. So this is a simple process, because if even the alpha particles have sufficient energy to remove the electrons from the materials, so then they are going to continue this process until it lost all of its energy. The last point is, since alpha particles are monoenergetic, monoenergetic means this is going to pass through a straight line having monoenergetic. Mono means same, energetic means the energy, having same energy and are not deflected from their path because passing through a straight line. They completely de-energize after passing the same distance, and this is called the range of the alpha particles. So here it is important, one is the path length and other one is the range of the alpha particles. Let me explain in this slide what is the difference between the path and the range. So the path is, let's suppose this is the electron is passing through the material, because this is having minus charge, and then in the material is also having the electrons present in the outer shell. So it may be diffracted with the interaction of the electrons. So it may change the path. So the path length is actual distance particle travels, but the range is the actual depth of the penetration in the matter. So let's put this is the path length. This is going because it is going to be deflected because of having the same uh, uh, charge on the electrons, or this is the negatron. Maybe this is the negatron. This is going to be deflected, and this is the range. That means from this point to this point, this is the actual depth of the penetration of the power. So you may say the path is more as compared to the depth of the penetration, and this depth of penetration in the matter is called the range. So in case of the negatron, the path is more than the range. So we are actually discussing the alpha radiation. So in this alpha radiation, because they are the mono energetic, they are passing through a straight line. So the path and the range is the same. That means the distance traveled, uh, the actual distance of the particle travel, and the actual depth of the penetration in the matter is the same in case of the alpha radiation, and alpha radiation is having the +2 charge over here. It is the helium nucleus. So this one is the important properties of the alpha radiation. So in this video you have learned that how does the alpha radiation is going to lose its energy. So see you in the next video to discuss the energy loss of the other radiations.